All right, we're now going to look at quadratic trig equations and possibly more. Okay, so solve for theta between 0 and 2 pi. Okay, same idea. So we're going to look at this one here. Sine squared theta equals 1/2. Because that's squared, we have a quadratic equation. Now this one's pretty easy to solve. It's like solving x squared equals 4. Well, in this case, you can bring the 4 over. It's x squared minus 4 equals 0. Then you factor, or you just jump right to the answer where x squared, not x squared, equals plus or minus this root of 4, which is 2. Okay? You can't forget the plus or minus. Same thing here. So square root of 1/2 is the root of 1 over root of 2, and this is how we get this answer. So the solutions to this are sine theta equals positive 1 over root 2, sine theta equals negative 1 over root 2. So when is sine theta positive? On the top half. When is sine theta negative? When y is negative, so in the bottom half. And when does sine theta equal 1 over root 2? Well, from our special triangles, that's when theta is pi over 4. So here are the answers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? Now, what about this one? So this one looks a little more difficult. So it's 2 sine cos squared theta plus cos theta minus 1 equals 0. So what you want to do with these is think of them in terms of polynomials. Replace the coses with just x. So this is the same as 2x squared plus x minus 1 equals 0. To solve this, you want to factor it or use the quadratic formula. Okay, so to factor it, I'm going to look at product and sum. Okay, so product I'm looking at is the first and the last. So product is negative 2. Okay, and the sum is positive 1. Okay, so the two numbers that multiply to negative 2 and add to 1 are going to be 2 and negative 1. Now using the fraction method to factor this, I'm going to put these two numbers over the leading coefficient, which is 2, and simplify those fractions. So 2 over 2 becomes 1 over 1. Negative 1 over 2 stays the same. Okay? So now we take these, and from this, we can factor that quadratic equation. So we take the bottom numbers, that's in front of the x. So 1x plus 1. 2x minus 1. And there it's factored. It's a lot faster than doing the decomposition method, but you're welcome to do decomposition if you wish. Okay? So, and the solutions then would be x equals negative 1 and x equals 1/2. Same thing over here. So if you can factor this way, then you just transfer it over here. So instead of x plus 1, it's cos theta plus 1, because cos theta is now our x. And then 2x minus 1 becomes 2 cos theta minus 1. Now we have cos theta equals negative 1, just like we had over here for x equals negative 1. Okay, and so cos theta equals negative 1, and cos theta equals 1/2. So when cos theta equals negative 1, we're all the way over here. We're at negative pi. When cos theta equals 1/2, while using our special triangles, we're at pi over 3 and 5 pi over 3. Okay, so those are our solutions to that, and that's how we get them. Okay, so we factor the quadratics and then solve. If it's factorable. If it's not, then you can use the quadratic formula. Okay, another one. Well, what if we have this? Same idea, change it over to a polynomial over here. Factor that. Okay, use product sum here. Product is negative 30, sum is 7. Two numbers are 10 and negative 3. Put them over the leading coefficient, 5 and 5. Reduce, 10 over 5 becomes 2 over 1. So 1x plus 2 is a factor. This stays the same, so 5x minus 3 is a factor. And we have answers x equals negative 2 and x equals 3/5. Okay, now back over here, transferring that over, we just do the same thing. So the x plus 2 becomes sine theta plus 2, and then 5 sine theta minus 3 is the 5x minus 3. So sine theta equals negative 2. Well, sine theta is between negative 1 and 1. So negative 2 is too low. If you think of the sine graph, okay, so sine theta, it's negative 1 and 1. So you can't go below negative 1 for sine theta or above 1. So negative 2 is down here. You're never going to hit it. So there's no solution for that. This one here, sine theta equals 3/5. So use your calculator in radian mode. Do sine inverse of 3/5, and that gives me theta r, the related acute angle in here. Okay, and then you do pi minus that to give you the other angle, and there's our two answers. Okay, so 0.64, pi minus 0.64 gives us 0.64 and 2.5. All right, so there's some quadratic trig equations. Let's look at some that are a little bit more complicated. Okay, so these are from the textbook, page 436. Just adding a little twist to some of these. Okay, so here's one. Secant x times cosecant x minus 2 cosecant x equals 0. Well, I noticed that cosecant is a common factor, so I'm going to take that out. Okay, so I've taken that out, and I'm going to solve this now. Cosecant x equals 0, and secant x equals 2. Well, cosecant is 1 over sine. If I tried to solve for sine in this, I would take the reciprocal. And the reciprocal of 0 is undefined. So there is no solution for this. And if you look at the cosecant graph, cosecant never equals 0. Okay? And so for this one, secant x equals 2, so take the reciprocal, would be cosine x equals 1/2. And we know for that, from our special triangles, x equals pi over 3 and 5 pi over 3. Okay, and here's a nice difficult one here. So 8d from the same page, so 436. So 8d, well, this is a little more interesting. So looking at this, you got 2 cotan x plus secant squared x equals 0. Well, these aren't even the same trig ratios. So we've got to do some magic here, use some trig identities to try and get it so that it's the same trig ratio. We didn't have it here that they're the same trig ratio, but we had a common factor so that we could do it. Here we don't have a common factor. Okay, so in this one, we're going to try and change it all to tan. So cotan x is 1 over tan x, so we're replacing that here. And secant squared x is the same, so it's one of our Pythagorean identities. It's 1 plus tan squared x. So now we have it all in terms of tan. Gonna get a common denominator now. So we multiply this top and bottom by tan x. So the tan x is on the bottom, and we got 2 plus tan x plus tan cubed x all over tan x equals 0. Now to solve this, like any rational equation, we have to solve when the top equals 0 and make sure the bottom doesn't equal 0 at the same place. The top is a cubic, so it's not a quadratic. Okay, so this is where there's a little extra. We got to go back to our knowledge of factoring cubics. So we're going to change this to something that looks like this, put the tan cubed out in front. So that's like solving x cubed plus x plus 2 equals 0. Call this p of x. Try some numbers that are factors of 2 to see if it makes it 0. P of negative 1 makes it 0, which implies that x plus 1 is a factor. Okay, so we're going to divide p of x by x plus 1, if you recall. And we get this, so using synthetic division. And p of x then factors to this. If we check this one here to factor it, because it's now a quadratic, well, we find out that the discriminant is negative, so it's not factorable. Okay, so you can't factor that anymore. Has no solutions if you set it equal to 0. So we're going to rewrite the top like this over here. Okay, so it becomes tan of x plus 1 times tan squared minus tan x plus 2, just like we had over here with the x's. Okay, still keep it over tan x though. Now, from the first one, tan of x equals 0. Tan of x plus 1 equals 0. We get tan of x equal to negative 1. And the solutions for that, well, tan of x equals negative 1 at 3 pi over 4 and 7 pi over 4. Okay, so you can look that up. Make sure that that's true. And from this one, we have no solutions. So we can finish this off with just x equals 3 pi over 4 and 7 pi over 4. And that's it for quadratic trig equations and more.